Welcome to Security Boundaries in Apex. My name is Dan Appelman. I'm the CTO at Full Circle CRM. I'm the author of the book Advanced Apex Programming for Salesforce.com and Force.com. For those of you who are wondering, the book is still about 99% current for Winter 15. There are a few changes. They're posted on advancedapex.com. So, you know, gratuitous plug, it's still a pretty cool book. Now, it turns out that since I don't work for Salesforce, and therefore I can say anything I want, I actually don't have to put up this slide. But I decided to put it up anyway because, as it turns out, safe harbors relate to security boundaries. And later on in this talk, you'll see why. So we'll get back to that. Meanwhile, I don't know, I think I've seen so many of these that I would miss it if it wasn't there. So let's start out with the question, what is a security boundary? Because I'm sure some of you came into this session and said, security boundaries in Apex? What is that? And the first part of this talk is going to be a little bit conceptual and philosophical. Bear with me. We will have examples and code towards the second part of this talk. To answer this question, what is a security boundary, I'm going to start and ask, well, what is security? Now, this sounds in a way like a stupid question, but it's also a very intimidating question because security intimidates us. And the reason it intimidates us is because we look at the real world and we look at, you know, Home Depot and Target and Chase and Bank of Europe and all these things, and we see that with all of their expertise and all of their resources, these companies who rely on security, they don't know how to do it. They can't get it right. They have break-ins every day. So how can we, as mere developers, possibly, you know, it must be a horrendously complex topic. It must be this horrific topic. And it turns out that security conceptually is very, very simple. And I'm going to teach you pretty much all you need to know about security from a conceptual point of view in 2 slides. One of the questions it asks is a list of things that you can do. For example, when you reach the door, you were granted permission, you came in here, and it asks the question, what can you do? You can sit down in this session. You can take out your laptop. You can watch your phone. You can take a nap. I prefer you don't, but you can do it. Security allows you to do that. There's a second security question, which is the same question but backwards. What are the things that you cannot do? For example, those people, if this session was full, some people were not allowed to come in here. If you use a knee defender to prevent the person in front of you from leaning their seat back, we might have to turn this session around and start over. So that is the flip side. It's sort of like a glass half empty, glass half full. And both perspectives are important. And for this session, we're going to focus on this one, the things you cannot do. We're going to look at security as a list of things that you are not allowed to do. So what is a security boundary? A security boundary represents the time and place where a security question is asked and answered. And security questions divide into mainly 2 questions. The first question is that of identity or authentication. Are you who you say you are? Now, when you came to the room, they scanned your badge. Here's my badge. How many of you have taken the time to install an NFC app on your phone and read your badge? Do that. It's pretty cool. You know, you see this cryptic thing and you sort of wonder, did they embed the data in the badge or is it all networked? I think it's all networked, but it's pretty cool. How many of you have a blue dot instead of a picture on your badge? How many of you are here on someone else's badge? You don't have to answer that. But this illustrates a point. This is what makes security challenging. It's not the question. The question of who you are is an easy question. It's the implementation. Now, I was at the Success keynote on the first day, and they talk about how in the Success community, to encourage community, we want to see your faces. We're going to really encourage everyone to put their profile on the badge. And seeing as I'm not a cynic, I would not think for a moment that it's to prevent things like badge swapping at a future Dreamforce. That said, how many of you flew in to the conference? Check your ID very carefully, don't they? Like multiple times. And you might think that, well, they started doing this for security reasons to prevent terrorism. Well, those of us who've been around for a while know that's not why they started doing IDs. Once upon a time, all you needed was a ticket. You'd flash that ticket, and they didn't care who you were. So people would buy tickets and say, oh, you know, it's like, I can't go here. Take my ticket. Go. That's what happened all the time. They started checking and enforcing identity on airlines when they invented the concept of non-transferable restricted fare tickets, right, to increase revenue. It's only later that it became an issue of security. So that's the trick with security. The questions, the concepts are easy. Implementation is where things get tricky. The second question that is addressed at a security boundary is the grant or blocking of permission. At the door, it was you may come in or you may not come in, one or the other. So this is the essence of security. This is what a security boundary is. Now, this talk, you know, like all the talks here are prepared a little bit in advance. And it turns out that the outline and so on for this talk appeared, it happened this summer while I was on vacation. I took an amazing vacation this summer. I was pretty much gone through all of July. And I'm sure you can understand, being on vacation, having to sneak in some time to prepare this talk, that I just had to sneak in a couple of my vacation photos. And here's the first one. Now, this is the UK border. Now, the UK border differs from the US border in the sense that when you get into a US customs hall, every 3 inches there's a big sign saying, no photography, no cell phones, you know, because every one of us is, I guess, a potential spy, and if we take a picture of a customs hall, who knows what will happen. But for some reason, I did not see any of those signs in the UK. I was still discreet, sort of pull out my phone and snap the picture, because this is a great example of a security boundary. The authentication at the security boundary is your passport. It has your picture, and that's telling them who you are, and they make sure they scan it, they make sure that you are who you say you are, and then they have to make a decision. They have to do an authorization. Do you enter the UK or do you not enter the UK? Now, hypothetically, let's say there was a reason that I should not have been allowed in the UK. For example, let's say I had not supported their football team in the World Cup. Well, at the border, let's say I lied about that, and I said, oh, yeah, I totally supported them, no problem, and they let me in. Well, once I'm in the UK, pretty much nobody's asking me anymore about who I supported in the World Cup. So the security boundary is really important because we do not check security continuously, right? We rely on our security boundary to do that gating. And this is very, very true in software, as you'll see. So when you talk about security, it's not enough ever to talk about just the authentication and just the authorization. You always have to think about the boundary, where and when you're checking, because that is frequently where you run into trouble. Now, here's another vacation photo. This is at the port of Mykonos. I got to tell you, I had a great vacation. When you get on a cruise ship, any of you been on a cruise ship? So you know the deal is they give you a card, like with the cruise line's label and your cabin information, and you show it at the port when you re-enter, you show it with your ID, and they let you into the port. Now, I love this picture for 2 reasons. First of all, because it is awfully nice to see that there's at least one place in the world that has security level green. I mean, you know, let's face it, in this country, the perpetual security level is somewhere between terror and panic red. So this I find very, very reassuring. And the second reason why I wanted to include this is that you leave today and you can honestly say that I was in a talk that had 2 safe harbor slides. I couldn't resist. Authentication on the platform, I know this is what you've been waiting for. It's pretty straightforward. The authentication part is here. For those of you using an API, it might be OAuth, it might be logging in with credentials and so on. There's a whole process of authenticating who you are. I'm not going to really go into that because it's pretty straightforward. We all know authentication. Authorization, well, authorization on the platform is a pretty big deal. There are lots of things that can get authorized or not authorized. But as developers, we're really going to focus only on 3 of them. First one is accessing records, which is, in a database, which records am I, as an individual, allowed to look at? This is called role-based security. This is where you have classes, the whole discussion of with sharing or without sharing. I'll show you some examples of that a little bit later. The second is accessing objects, or object security, often referred to CRUD security, based on create, read, update, delete, not how you feel when you're doing security programming. Well, it is how you feel when you're doing security programming, but that's another story. The last one is field level security, or FLS, accessing object fields. And these are the three main ones that we're going to focus on. Now, I got to tell you, if you've come from if you've come from the admin world to be a developer, this is sort of like, okay, I get it, easy, I know field level security, I know about object security, I know. But if you've come to force.com from another platform, you know that this stuff is amazing. This is miraculous. I mean, the Windows people doing like SQL and all, they have nothing like this. Each developer has to build their own security framework, which is one of the reasons why there are so many security violations everywhere, because everybody's building their own security system, their own security boundaries from scratch, and sometimes they fail. So this is really cool. This is like magic. Now, how this is implemented depends on whether you're a declarative developer or an Apex developer. Now, in the declarative world, it's easy. The Salesforce user interface is your security boundary. If you deny a user permission to access a field, that field vanishes. It disappears from the page layout. It disappears from reports. It disappears from the UI. It's amazing. It's magical. I cannot stress enough how fantastic this is. Now, when you're a developer, however, things are a little bit different. With the development, when you're in Apex, it's not magical. There are two places where security is enforced, where the security boundary is implemented for you as an Apex developer. The first place is the record access, sharing rules, is implemented at the SOQL level. In other words, if I am executing code in a class that's defined with sharing, and I perform a query, that query will respect the existing sharing rules and the role-based security. It will not respect it if it's without sharing, it will not respect it at all. When it comes to object and field level security, the only place in Apex where these are enforced is when you're working with a standard object controller. And think about it, standard object controllers are part of the UI system, right? And we already know that the UI is where the declarative developers see the security boundary. Well, that's actually where it's implemented. It's implemented in the UI, not in Apex. There's nothing in Apex to enforce field level or object security. Now, every now and then you have a developer say, well, this is terrible. Why don't they build it into the system? Make it easy on us. Well, there are two reasons for that. The first reason is, can you imagine the impact on performance if every time you accessed a field or tried to update a field or anything like that, it did a security check? I mean, all of your software would probably run like 5 times slower, and they're trying to increase the number of transactions, right, and get rid of limits and enable us to create better, more responsive applications. If you bake security into that level, it would be horrific. For the same reason that we have security boundaries in the first place, that we're not constantly asking every single person in this room, oh, are you still allowed to be here? Are you still allowed to be here? No, we trust you. You came in the door. You're allowed to be here. The other reason is because, as it turns out, there are a huge number of design patterns of very useful, essential application designs that require you to be able to access any object, any field, and I'm going to show you exactly why that is. This is what you're supposed to do, right? They don't talk a lot about this in the language reference. What they pretty much say is if you want to do things correctly, you should perform a describe operation and check, is that field or object updatable? So for example, in this case, the first example is the email field updatable? For this user, can I update the email? So you do that check, and based on that, you decide whether they can or can't update the email. Is a contact a deletable object? Do we allow this particular user their Apex code to delete a contact? So the documentation says, just respect this. Just do this and respect it. And the reason they offer a simple solution like this is because it is simple, and it increases the chances that people will do it. Because let's face it, most developers do not. I mean, those of you who have looked at code that some consultant has written in an org, how many of you have seen good, consistent use of these design patterns to check security? How many of you have seen it missing? And the reason it's missing is because it's hard and it's costly. And every time you do this, it increases the chances that something's not going to work, right? That's the nature of security, things you can't do. It prevents you from doing things. So hopefully we give people a simple solution, a simple way to do it, and everyone will do it. They don't, but at least you can offer the hope, the possibility. But we're not going to worry about that. What we're going to worry about are other kinds of design patterns where you really don't want to do this, and you have good reasons not to do this. Now, I want to imagine for a moment that you work at Dilbert's company. Now, I'm hoping, if you're a developer, you probably know who Dilbert is, yes? Has anyone never heard of Dilbert? Maybe one or two. So if you have never heard of Dilbert, it's a comic strip. Look it up, because it is our lives as developers. In Dilbert's company, everyone except you is incompetent. Everyone except you is completely self-centered. And maybe everyone, again, except for you, is just a tiny bit malicious. Now, of course, none of you work for that kind of company, and I'm glad to know that. I'm glad that you all feel comfortable where you work. But it's possible that someday you might have to take a job at Dilbert's company, or more likely, end up doing some consulting work for Dilbert's company. And that is sort of our pattern, the prototypical company that we're going to be thinking about. A little bit of malicious, a little bit of incompetent, a lot of incompetence. And here's the requirement. We want to do Lead SLA, Service Level Agreement. And the idea is a lead comes into a salesperson, and we want to set a date on that lead, say 3 days in the future, sometime in the future, by which time, if the salesperson has not done something, acted on that lead, we will report on it or flag it or do a big warning error or something, right? How many of you have ever done an SLA, some kind of SLA work? Fair number. This is a very real-world kind of situation. So let's imagine again, you come in, you do that, and you build a real simple solution. You add this field to the lead. We're going to call it ABSLA date, and we're going to set it to 3 days in the future every time the lead's inserted. Now, obviously, if all you wanted to do was set it 3 days in the future, you'd probably use a workflow or something. But the real world is that you wouldn't want to use 3 days in the future because, salespeople sometimes are on vacation. You want to give them some more time, or it's a holiday, or it's a weekend, or they're weird business hours. So the actual code to figure out what is the real SLA time, to be fair, can actually be incredibly complicated, especially once you get into international salespeople and time zones and different vacation schedules in different countries. It could actually be, you can have a whole application just to figure out what is an SLA date. So this is just an illustrative example, but it does make sense that this is the kind of thing that you would do in Apex. So the company does this. They implement it. It's great. Everyone's happy. And hurrah, 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 every salesperson always meets their SLA. Everyone gets their bonuses. Managers are happy. Boss is happy. Everything is cool. Until one day some snarky intern comes up and he says, you know that that SLA date thing's on the page layout, and all the salespeople are just editing it to, you know. So of course they're all perfect. And you say, oh dear, what are we going to do about that? Now, those of you who have admin background will say, well, I'm going to make it read-only on the page layout. But this is Dilbert's company. And at Dilbert's company, you don't have one page layout, and you don't have a competent admin, right? You got 100-page layouts, you got 1 billion profiles, and they're all like political turf and so on. And the chances that you, as a consultant, are going to convince them to change a page layout, it's not going to happen, especially if it means that some salespeople are going to lose their bonuses. Besides, the salespeople have buddies in the developer world who can, you know, do some anonymous Apex. I mean, there's stuff going on there, right? The security question's easy, but boy, there are a lot of holes. So you say to yourself, well, this is a great place for field-level security. I'm going to lock down that field from everyone. Nobody can touch it. Nobody. And I can do that because Apex code doesn't respect field-level security. What we're doing in this case is we're saying we're going to block access to that field from everybody as much as possible. We're going to block it from the API because API logins respect the user credentials. But we're going to treat Apex code as a sort of a super user. We are going to delegate the authority to set that field to our code. And this is a hugely powerful concept. And this is a really important design pattern to be able to do this. Okay, so this is good. Now let's get a little bit more sophisticated. And we're going to come up with a new requirement. And the idea here is when the lead status changes from whatever the default lead status is, I want to create a new object. I'm going to log whether that lead was in or outside of the SLA period. And this is going to provide me some really valuable information, right? It's going to tell me historically I can see trends over time, if things are improving or not improving. I can drill down to individual salespeople and see their statistics. Really, really cool, useful stuff. Now, obviously, we're going to block off access to that object for everyone other than code, just like we did blocked off that lead field, right? So that's sort of a no-brainer. This is a great example. This is another example that we saw earlier of where we're going to delegate the authority to the code to do this kind of work. But we're going to get a little farther. So I'm actually going to show you a little bit about what this looks like. Hang on. All right. So here's an example of how you might do this. We'll have a custom object. And the custom object will have some custom fields where we're going to keep track of the new status, the prior status, which will, I think in this example, will always be the default status. And we're going to have a checkbox to see whether it's within the SLA or not. And the trigger for something like this might look a little bit like this. So we have two cases. We're going to handle both the before insert and before update here. Before insert is what you saw earlier. We're just going to set the date to 3 days past today. Before update, we get a little trickier. We're going to take a look and see first we're going to get the default status for the lead because we don't want to hard code that. And one of the nice things about ever since summer 4, no, is it winter 15? Anyway, just now I think they took away describe limits, which is really, really cool. Until recently, you could only call 100 of these describe statements in an execution context, which is completely useless if your objects have a large number of fields or if you're dealing with multiple objects. But now it's unlimited and it's fast. So you can go ahead and call it at any time you want. So we're going to get the pick list status values. We're going to go through and we're going to see if the status has changed, if it's changed, and if it's changed from the previous status. And we're going to go ahead and add a log entry. This is reasonably bulk safe. There is an error in this code. I don't know if anyone can spot it, but I'll give you a hint for you to think about later. What kind of workflow would cause multiple log entries to be entered. And what would you do about it? So that's something to think about, sort of not part of the topic of this course, but I didn't want to add too much more complexity to this, but it's something sort of to think about for the future. But otherwise, it's a pretty decent piece of code. This is the way people would normally do it. Okay, so we're going to create these log entries, and now we have these log entries, and what you might want to do is report on them. Now, if you are if you're an admin, okay, here are all the records. So I have 3 sample records, and as you can see, 2 of them were within SLA, 1 of them wasn't. Now, these were created by different users, and I have a login of a different user here. There we are. And here, same page, same list, I only get 1. Good. And the reason I only get 1 is because reports, like everything else in the UI, respect role-based security. So I have set these things up so that with the sharing rules are set up so that you can only see that this object is private and you're only allowed to see the ones that relate to you or to people who are on your team. Now, in terms of the requirements, think about it. We want salespeople to see their own data. We would want a sales manager to see the detailed sales data for their team, but we would not want marketing to see individual records. We want marketing to only see aggregate data. Now, why would this be? Because in Dilbert's organization, marketing and sales are enemies, right? And the last thing in the world that, if the salespeople thought for a moment that someone in marketing could see their individual history, they'd all quit, right? Or burn the building down or something like that. So you want marketing to only see the aggregate results for the entire organization. You don't want to allow them to drill down and see individual records, right? And you might want to break it down so that they can see aggregate data over periods of time. And maybe you would set it up so it would be by division or some other criteria, but definitely not individual data. So the way we implement that aggregation is we're going to set sharing to default, as you saw, so that people can only see their own records. And we're going to use Visualforce and Apex, which, again, Apex can bypass those sharing rules to get the aggregate data. And it might look something like this. So here's an example of a Visualforce controller. And it's a very brute force system where what we're doing is we're just querying all the log entries. We're looking at the total number, and we're counting how many of them have the within SLA set to 1. Now, at first glance, you might think this is a really awful design pattern. And it's because, in a certain sense, it is. But it's not as bad as you might think, because the Visualforce page that calls it is set read-only. And when you set it read-only, you can basically query vast numbers of records. So this actually will scale to a fair degree. It's not awful. In a real implementation, you would probably also do some date filtering in there as well, so that you're not looking at all the org's records. And you probably would want to set up some system where you're getting rid of older data or archiving it somewhere. But certainly for this example, it's pretty straightforward. Now, I actually have 2 of these classes. First one of these is defined with sharing. This is SLA Log Controller 1, or Log Controller, and the other is SLA Log Controller 2, which is defined without sharing. Now, when I look at these 2 pages, the page itself is very, very straightforward. You have the page. You can see that it's set to read-only, so we can see large numbers of records. We're not going to be modifying any data on this page. And we have the controller, SLA Log Controller. Our display is very simple. You can see this many out of the total SLAs were within the SLA period. Now, on our administrator page, administrator for login, you can see 2 of 3. 2 of 3. Go ahead and refresh it so you can see it's real. The only difference between these is one is Log Controller 1, one is Log Controller 2. Remember that Log Controller is the one with sharing, Log Controller 2 is without. When we're on a system administrator account, they can see all the records anyway, same data. But when I go to my other user, who is not that one, but this one here, then we go to SLA log page 1. This is with sharing. It says only 1 out of the 1 lead, 1 out of 1. In other words, the one that belongs to this particular user that user is allowed to see, that's all the query returned, right? So this is sort of proof that the so-called query is the boundary for role-based security. Now, my marketing page that uses the controller that's defined without sharing, even though I'm logged in under a restricted user, can see 2 out of 3 leads. So they can still, even though they do not have permission to see all of the org's data, nevertheless, you can surface aggregate data that's based on all of the org's data because you used without sharing. This is really cool. This way, your marketing users don't have to be sysadmins. They don't have to have access to everything. You can surface the data that they need. And what's more, you can secure access to the visual force page to make sure that only they can see it and maybe prevent the salespeople from seeing it. So you can sort of reduce friction in Dilbert's org. So that's what I just said. So here are the principles to think about when you're working and building Apex code where you really are defining your own security boundaries. First of all, it is really important not to expose restricted data. So that earlier design pattern that you saw, where you use describe statements to say, is it editable, is it creatable, and so on, you should use that. And you should make sure, especially if you're not using a standard controller, you should make sure that you are respecting those when it comes to data that is secured. If it's secured, if someone intended to secure it, it's important that your code respect that. However, you are allowed in Apex to create code that looks at all kinds of data and creates new data and creates aggregate data, and that aggregated data is not secured and does not need to be secured by the source data. You've created something new. So the built-in security system doesn't necessarily define what is the security on that. It's up to you to define what is the security on this aggregated data. There's a concept in computer science in many platforms called impersonation, the ability for you to create code that runs in the context of an arbitrary user. The only place this exists in Apex is in unit testing. It does not exist in real code. But even though Apex lacks impersonation, this concept of using Apex as a super user that's able to do things on your behalf is incredibly powerful, and you can use it in many, many places. Now, how many people here create managed packages? Any ISVs? We got a good number. Okay, this is for you. Okay, do not, actually this is not for you. This is for developers and consultants. Sorry, I'll get to you in a minute. For developers and consultants, everyone. I know your clients will not pay for this. Try to get them to pay for it. Do as much as you can to build and test with security. And I'm not going to pretend that it's easy or it's cheap or that you're going to do it, because I know that you're not, because it costs money, you're on a tight deadline, and so on. And when you cannot do it or do not do it, don't be hard on yourself, don't feel bad, because this is the nature of our industry. Be aware of it at least, know what you're doing, know where you are making those compromises, maybe flag it to the customer and say, you sure you don't want to do this? And by default, get in the habit of using the standard design patterns for CRUD and field level security, even if you have to take it out later because things don't work. But at least if you have every class defined with sharing by default, if you use CRUD FLS where possible, it increases the chances that things will be good. Now, I apologize for the slight diversion. For the managed package vendors, for the ISVs, you have to pay attention to this stuff because you will not pass security review if you don't. If you do any of the things I've described here today, you will not pass security review. It will bounce. Of course, they will bounce pretty much anything for any reasons, but that's another story. Here's the trick. What they're looking for are people who don't get it. They're looking for people who pay no attention to security. If you are using these design patterns, if you are intentionally bypassing security in order to achieve a certain effect, like aggregate data, like logging data. In our application, for example, we log diagnostic data. We don't want anyone to look at it. We have internal objects. We don't want anyone to access it. Our recommendation is for users to lock those down. We delegate authority to code to access that data. And when your package fails security review, which it did, like ours did, then you create what's called a false positive document, where you write up in great detail exactly what you're doing and why you're doing it. Now, the good news is that the security review team, most of them, are really sharp. They actually get it. So if they know, if they can see that you actually do know what you're talking about, that you have a legitimate design pattern for why you are creating a class that's without sharing, why you are not checking field level security, if you show them that you have a security plan, a security design in place, they will pass you because they get it. They understand that these kind of security design patterns do exist and that they're incredibly valuable. But as an ISV, you have to make the effort to show them that you understand what you're doing. All right, that's the show. We're going to open it up now for any questions. We have a few minutes. And there we are. Do we have any questions? Please come to the microphone because I cannot see hands. So if you have any questions, don't be embarrassed. I can't see you. Everyone in the audience can, but I can't see you. Yes.
So for the field level security, the with sharing and without sharing doesn't address that, right?
I'm sorry?
So record sharing is addressed by with sharing and without sharing.
Yeah.
But not the field level security.
Sharing and without sharing only controls role-based security. It
Right.
does not control field level security. It does not control object CRUD security at all.
Right, so we have to basically write, is this field accessible or writable or readable always, right?
Yeah.
There are no shortcuts for that, right?
There are no shortcuts. There are some frameworks out there that try to help you support that kind of functionality. They do some weird things like making copies of objects and then only copying back the ones that are secured and not. It's sort of painful. I wish I could tell you this stuff was easy, but it's not. It does take some thought. Any other questions? All right, well, I'll be here for a while if anyone has any questions. Thank you for coming. I hope you enjoy the rest of Dreamforce.